Hi, everybody. Welcome to our webinar today. We're going to give everybody just a couple of minutes to get online here, and then we'll get started. All right, we're going to get started in about a minute. So thanks, everybody. All right, we're going to go ahead and get started. I know that New Hampshire and Vermont are getting a lot of snow today, so it looks like it's definitely cut back on our number of participants, but we're going to go ahead and get started. And I'm hoping again in the next few weeks that I have these posted to the HMC or Hazardous Materials Consulting website, so you'll be able to watch them again or share them with anybody else that you'd like. So let's go ahead and get started. So today, we're going to be talking about safe storage strategies for science chemicals. I'm going to give you a lot of little tips to make sure that as you're moving things around in your stock rooms and getting them in, separating out the things that you want to keep and continue to use, that we store them correctly and most safely. And so we're going to go through a lot of information today. All right, so we'll go ahead and get started. So I'm Becky Anderson, and I'm a hazardous materials chemist, and I've worked with schools for more than 25 years, trying to help make sure that they stay safe in chemical management, both in the sciences and then also throughout other areas of the school. I want to take just a second to thank Vicki Davis. Vicki is with the Upper Valley Lake Sunapee Regional Planning Commission. And Vicki is the one that was responsible predominantly for getting this funding. I also want to take just a quick second to thank EPA Region 1 for the funding for this webinar. Without the funding, we wouldn't be able to be doing this. So we really appreciate that. And then finally, I want to just, do a tip of the hat to Dave Waddell, my mentor, the gentleman that trained me and worked with me for several years on various science safety in schools programs. And he's provided us with a lot of resources as well as, and some of the photos from today will be from Dave. So just wanted to say that. So the goal of all of these webinars, so we're putting in a series of 12 of them. There will be 10 done between, we started last month and they'll go till the end of May. 10 during that time frame, and then 2 more in August. And the intent of these is to help educate teachers, administrators, and anyone else that's involved in school chemical management, the safest ways that they can manage those chemicals and to minimize risk as much as possible on at school facilities. So here's just a quick little technical overview of what we're doing with the webinar today. So if you have any questions as we're moving forward, please put them in the question and answer box. All right, and I'll be keeping an eye on that. And then at the end of our session today, I'll try to get those questions answered. We also are going to have some links today to various websites that might be able to help you out with additional information. And those will come, you'll be able to see those in the chat. But you won't be able to comment or write anything in the chat. Please put your comments questions in the question and answer box. We also have closed captioning if that helps you out. We do have the raising the hand thing. We have that disabled, so you won't be able to do that. So if you do have any questions, again, question and answer box. And then the audio settings are down in the bottom left. If you have any troubles hearing things and you want to make sure that it's set at same as system, that will help you out. So, okay, we're going to talk about topics for today. So as a review of previous webinars, we started off looking to determine if we had legacy chemicals in our schools. And then one of the first things that we talked about in the very first webinar was what are the dangerous legacy chemicals that we need to look for? What are the ones that we do not want to move around because they present an extreme level of risk, shock sensitive, friction sensitive, photosensitive explosives. And those were all addressed in the first webinar. Again, over the next few weeks, I hope to have those webinars accessible to anybody who wants to watch them through the Hazardous Materials Consulting website. I'm just having some technical challenges in getting them done, so I'll be working on that. We also looked, once we identified whether or not we had legacy chemicals, we then began looking at the chemicals that we want to keep. And we used 4 criteria to determine whether or not a chemical should be kept and used in various labs. And those criteria were, is the container in good shape or is it compromised? Do we have an excess amount of this chemical? Is the chemical dangerous to the point that the risk of using that chemical exceeds the utility? And I can't remember what the 4th criteria was off the top of my head, so I'll have to go back and check too. But we had 4 criteria to identify whether or not we wanted to keep a chemical on site. Once we've identified that we want to keep a chemical and you've built a list of those chemicals or an inventory, an electronic inventory is best. Then what we're doing today is we're going to get your chemical stockroom set up so that we can store those chemicals that you want to keep and use in your lab safely. We're going to start with some pre-planning of your chemical stockroom. So some things that you'll need to be aware of for safety measures in the chemical stockroom that should be in place. Then we're going to talk about how the best way to store chemicals, which is by chemical compatibility or chemical compatibility class. And we'll go through some examples of that. And then finally, we'll end up discussing storage of waste, particularly hazardous waste that results from the chemicals that you've been using in your labs. So that's kind of where we're headed. All right. Okay, so final housekeeping items. Please again, make sure that you post any questions in the question and answer box, and I'll try to get those either as we're going through the webinar or I'll address them at the end. There are times that they're really complicated and we get too much into the weeds. And in those instances, you're welcome to email me. On the very last slide of the presentation will be my contact information. You're welcome to email me. You're welcome to email Vicki Davis, and we will work with you to get your questions answered. Also, you'll notice there's a disclaimer on the bottom of this, and basically that's just to make sure that that you know that this information is pertinent and correct and in compliance with the regulations that are in place now in 2024. So if you happen to be watching this webinar at a later date, please know that you need to really check the regulations to see if they have changed. Okay, let's go ahead and talk about working in the stockroom. So the first thing we want to make sure that we're doing is we want to leave any of those dangerous legacy chemicals in place. We want to isolate them, and we're going to do that not by moving the legacy chemicals, but by moving the chemicals that are around them. Again, some of these chemicals have become shock sensitive explosives. We do not want to pick them up and move them around and irritate them and set them off. Okay. Now, I get a lot of questions. Are these, if I find any of these dangerous legacy chemicals, is this an emergency? It is not an emergency as long as those chemicals are left in place. Keep in mind, they've been sitting there for 40, 50, 60, 80 years and nothing has happened. And so what we want to do is we just want to leave them, you know, happily quiet where they're sitting, so as we figure out a mechanism to dispose of them. So if you have any of those that you found, please reach out to me and let me know. And I'm happy to talk through and help you with strategies to get rid of those. In the previous webinars, we've talked about having a map of your classroom safety equipment. We really want to have that done so that it's part of your chemical hygiene plan, which we'll be discussing in the next couple of webinars. We want to make sure we have adequate spill materials. So before you go in and start moving things around in that stockroom, check the spill materials that you have. We're actually going to go through in depth today some of the components that would be helpful to you in your spill kits. We want to make sure that you have on the proper personal protective equipment so that you are protected in case anything goes sideways when you're moving chemicals around. We always want to make sure that we have those things safe and or that we have that equipment in place so that we are protected. Some of the key things that you want to think about are goggles, definitely safety glasses, and actually, if you're moving around things in your stockroom, I would really encourage you to use chemical resistant goggles, just so that you can protect yourself from some of the vapors that are coming off of some of those different chemicals. Want to make sure that you have disposable gloves, disposable and chemical resistant gloves. Typically, I like to see 2 or 4 mil nitrile gloves. Those are the ones that I prefer. We'd like it to have you in a lab apron and clothing that covers your legs. That way, if we have anything that breaks open, you're not going to get splashed on your body. We also want to make sure that we're in closed-toed shoes. So, and then I'm going to encourage you to sit down before you start moving chemicals around and discuss a spill response plan. So what are the action steps you're going to take, and who are you going to work with if you do have an inadvertent event and something spills as you're moving things around and organizing them? Now, one of the things I want you to keep in mind as you're moving forward with this stockroom reorganization and organizing your chemicals by compatibility class is that this is likely not going to be just a one-day event unless you have a really efficient, pretty amazing plan and colleagues to work with. It's likely going to take you a couple of days. Most of the teachers that I've worked with on this throughout the year have done reorganization of their chemicals over winter break, over summer break. Sometimes they'll take a student plan or a teacher planning day and work with them then. You also want to make sure that you're only working with colleagues, administration, or facilities personnel. No students should be helping you with the reorganization of your science stockroom. One of the first things that we want to look at is just your stockroom in general. A lot of times what I've seen over the years is that they are just packed full of stuff. And it's papers from teachers from long ago. It's unused, unidentified stock solutions. It's old equipment that is no longer used. It's things with missing parts, broken lab equipment, all of those types of things. And they take up that type of material takes up so much extra space that it really eliminates a lot of usable area that you could be coordinating and storing your chemicals in a much safer manner. So I'm going to encourage you that, before you go in, work with your colleagues and start eliminating a lot of that old stuff. Now, sometimes teachers will get the approval to just throw some of it away. Some of it can be placed in long-term storage in the event that somewhere 10 years from now, somebody decides that they need an old spectrophotometer or who knows what, series of microscopes, anything like that. So if you're not using it now, but you think that it might have some utility in the future, please work with your facilities folks to see if there's long-term storage someplace other than your stockroom. You'll want to work with your facilities folks to get trash cans and make sure that you have access to waste disposal. Now, I want to remind you again that chemicals don't go in the trash. Nothing hazardous should go down the drain, up the fume hood, or in the trash. And if you have any questions about whether or not something is hazardous and needs to be handled specially, set it off to the side, err on the side of caution, and work with either your regulators or reach out to me and I can help you determine whether or not something is hazardous to the point that it needs to be managed as a hazardous waste. Flynn Scientific, I want to give a little shout out to them. And Rosa, if you could put up the Flynn Scientific information. Flynn Scientific is one of those companies that I've worked with over the years, and they provide exceptional information to teachers, and a lot of it is free. They have a lot of Flynn freebies on their website. So I want to make sure that you're out there and taking a look at that information collection that they have. I would caution you, however, that they used to send out a catalog with waste disposal methodologies in the back. And I believe that's still in their catalog. If that information is still in their catalog, I would encourage you to be very, very cautious, because a lot of their information is based on regulations at a federal level and not state to state. And so there are actually things in their disposal guidance that if you do them in some states, they're actually illegal. So please be very cautious when you're referencing or using the Flynn disposal methods. And again, I would encourage you to reach out to your state specifically for information. One of the things that Flynn has guidance on is a methodology to going through and cleaning out your chemical stockrooms. And there's a lot of good information. And one of the things that they state pretty frequently is that you should be ruthless in your cleanup. And I really liked that terminology. So I want you to go into your stockrooms and I want you to be ruthless. If it hasn't been used by you or any colleagues in 3 years, I think that those are things that can probably go into either deep storage, be thrown away, or be tucked way back in a corner up on the top shelves in places where they're not going to get in the way of the things that you're using all the time. Okay. I get a lot of questions. Well, there's some really cool stuff in there, and can I sell that on whatever web marketplace website? I'm going to tell you, for chemicals, the answer would be, my recommendation is no. Chemicals are, number one, it's very dangerous to share your chemicals with others when you don't know what their intents are. Number two, it's very, very challenging to ship chemicals legally and follow and meet all of the DOT criteria. And the last thing that you want to do is try to salvage something and sell it for $5 and face a $30,000 DOT shipping penalty. So I'm going to encourage you, do not sell chemicals on websites. Labware, maybe. Again, we're going to really be cautious with who we sell this to and how we sell it. And you're going to have to check with your school's administration to see if this is even a possibility. Overall, I'm going to tell you that there's a lot of lab equipment out there on various government and web marketplace sites, and most of it goes for pennies on the dollar. And I really don't think, over the years of doing this, I have not found that this is a really good magical solution for funding a clean out. There just is not. It takes a lot of time and effort. There's a lot of risk associated with it. So I would encourage you not to mess with trying to sell things on any websites. It's just not worth it. All right. Before we start moving things around in the stockroom, before we start segregating and sorting our chemicals, I'm going to strongly encourage you to sit down with your colleagues, sit down with your safety team, and talk through a few scenarios. Make sure that you have a plan and action items for who's going to do what. If you do have such things as leaking containers, if you go pick up a bottle and the bottom falls out of it. We had this happen with an ammonium hydroxide bottle several years ago at a high school, and it resulted in the evacuation of the high school. If you find residual debris on your shelves, way tucked in the back, gooing up your shelving, what are you going to do about that? How are you going to clean it? How would you define what is a good cleaner that will not react with what you're doing? What if you discover that you have shelving that's broken or too weak to hold chemicals? These are the scenarios that I'd like you to talk through and make sure that you have a plan for. I'm going to also encourage you to come up with a concise, written spill response plan. That is a part of your chemical hygiene plan. It's also a part of a number of other OSHA and fire code requirements. So I really think it's a good idea for you to talk through some different scenarios, work with your colleagues and draft up, and it doesn't have to be pages long. Couple of paragraphs of where's our spill kit, what are we going to use, and who are we going to call for guidance. You want to build a list of emergency contact numbers, the facility personnel, administrators. There might be private companies to help you assist with chemical cleanups. Maine Lab Pack is working with the state of New Hampshire to go in and help assess chemicals and help develop disposal inventories. They may have some ideas, or I don't know that Maine Lab Pack does emergency response or quick response, but they may have some ideas of companies that do. You'll also want to make sure that you know how to get a hold of your emergency responders in case you do have a plan or a problem with exposure. Preparing for these scenarios and concisely capturing what your spill response would be or what your response would be in each of these types of emergencies makes an excellent section in your chemical hygiene plan. And it is a requirement. So it's definitely worth your time to spend some time pre-planning. When we, in the emergency response community, when we sit down with our colleagues and we talk about what would we do if I pick up a 4-liter bottle of ammonium hydroxide and the silicates in the glass are so weak the bottom falls out. And now I've got this giant, stinky, rotten ammonium hydroxide spill. How am I going to fix that? How am I going to clean it up? In the emergency response community, we call those tabletops. And it is very, very valuable for you to start identifying what the risks are and thinking through what your response would be, and then writing those down. All right, this is a really nice slide that gives you a good list of components to have in a make your own spill kit. Spill kits, if you just buy them from any of the online suppliers, can get to be very, very expensive very quickly. So this is a list of a number of things that I would include in a spill kit. And then I've also put the pricing by the slide, and I'll see if we can I'll see if there's a way that we can capture this slide and put it specifically out on my website as well, so that you have access to it. But basically what it covers that you want to include in your chemical spill, your spill kit, are things like universal spill pads. I would also encourage you to keep like a 40-pound bag of clay kitty litter. This is the super cheap kitty litter, just clay. You don't want any additives. You don't want the fancy crystals or the smelly stuff. None of those kinds of things. We just want simple clay kitty litter. Oil dry is another name for a clay absorbent material. Those are the two primary things that you're going to want to have very fast access to. As you're working with chemicals, if you do drop something or something happens, we want to make sure that we switch from disposable nitrile gloves to heavy duty nitrile gloves. Have on a chemical apron. I'm going to encourage you to throw on some shoe coverings so that we're not contaminating your shoes and then spreading that all throughout, the school and your house and your car and everywhere else. Chemical resistant goggles. The favorite ones that I have are called UVEX, UVEX Flex Seal goggles. And I'll see if I can put that in I am not figuring out how to put it in the chat. Oh, there we go. So they're called UVEX Flex Seal. And they're very comfortable. They're also, you can buy them with anti-fog coating on them. You need to have a pair of those in your chemical spill kit. What I'd encourage you to have, use your, for the chemical spill kit, I would encourage you to get a 5-gallon bucket and use what's called a gamma seal lid on it. What this is it's a tight fitting lid that goes on the top of the 5-gallon bucket, but you can spin the inside of the lid to remove it. And that way you still have a good seal on the bucket, but you can access in and out of the bucket. So it's called a gamma seal lid. They're kind of unusual. I would encourage you to have those and then just put all of your spill kit contents, except for the kitty litter, right in that bucket. They should almost, if you stuff it really full, they should be able to fit in there pretty easily. Once you do that, make sure you label that a spill kit and then that can stay in your classroom. Other things that you might want to have: gallon Ziploc bags make excellent secondary containment, not for all solvents, but actually for quite a few different solvents. So if you've got anything that is leaking or gooey or the cap is broken, that might be a nice option for you, is to drop that container very gently. Don't drop it, just set it in a gallon zip seal bag and close it up, and then set it on the shelf for the disposal company. Also in your spill kit, a disposable hand broom and dustpan. And then if you have not gone through a targeted mercury cleanout, it's highly likely that you're going to find mercury thermometers and other mercury compounds. Mercury thermometers themselves are just a beast to deal with, because the problem is if we drop one, to get that mercury cleaned up to an acceptable level of exposure is very, very, very difficult and very expensive. So you can purchase a mercury spill kit that will absorb the mercury for about $70 or $75. I put an example up there. It's just available out on the internet. I would only have, because those are expensive, I would have one mercury spill kit per school. I would not put one mercury spill kit in every single spill kit. The total contents, once we have all of this and we add it all up, without that mercury spill kit, it ends up being between $100 and $110 for a spill kit. Really, that is very affordable when you compare them to the pre-made ones that are $250 and up. Once you do, or if you do have a spill and you use any of the contents of the spill kit, make sure they get refilled. And then you can use your 5-gallon bucket as the containment, as the disposal container for any of the debris that's been contaminated in the spill cleanup. All right. If you have any questions on that, please make sure you drop those into the question and answer box, or reach out to me on email and I can help you with that as well. One of the things that I want you to think about with your spill kits, though, is to also make sure that you know what your limits are. Concentrated acids, concentrated bases, if we drop one of those, depending on a lot of different conditions, I want you to really evaluate, can you safely clean that up without causing any damage to your lungs and your respiratory tract? One of the things I want you to notice is on that spill kit, I do not include any respiratory protection whatsoever. And the reason is that respiratory protection, things like air purifying respirators or anything like that, those all fall under significant amounts of OSHA regulation, and they include what's called medical monitoring requirements. Because of that, if you've got something that's going to affect your respiratory tract, that's an indication that you should leave those chemicals, leave that spill where it's at, evacuate the area, and call for assistance. Okay, I'm going to say that again. If you spill something and you can feel it burning your throat, burning your eyes, causing you to cough, giving you a weird taste in your mouth, you need to leave the area, alert everyone else in the area to leave, close the door to that classroom and don't let anybody in it. And then go request assistance from either a contracted chemical cleanup company or your emergency response cleanup companies. Okay, or your first responders, your fire department hazmat teams. Okay, please make sure that you don't expose yourself to any of those vapors and fumes that can cause significant damage to your respiratory tract if you do have a spill. You can buy some of these things in bulk, like you can buy the universal spill pads at 100 per box. Pretty darn affordable to buy them in bulk that way. And then you can divide those up amongst several classrooms. So I've worked with several school districts where we took a half day, sat down and just built 10 spill kits, one for art, one for maintenance, one for facilities or bus barn, one for industrial tech or shop areas, and then one for each of the different science labs. And it works really well if you sit down and you just kind of build them all together. Okay, next things that we're going to talk about are more difficult. Spill kits are actually pretty darn easy compared to this. One of the first things that I want to talk about is ventilation, and this comes up all the time with schools. Most of our chemical stock rooms are essentially kind of like old dark closets. I've been in and out hundreds of them over the years. This is not an ideal situation. Ideally, what we want is we want high levels of ventilation in these chemical stock rooms. And high levels of ventilation, I'm talking about 6 to 7 air exchanges per hour just in that room. And that exhaust is exhausted directly to the outside. We do not want to exhaust that into the rest of the building's exhaust air. It needs to be a direct exhaust to the outside. The reason for that is if we're exhausting out acid vapors, for example, we don't want to eat the rest of the HVAC building ventilation with those vapors and then have those seep into other classrooms. So building proper ventilation for a chemical stockroom is really tough. Stanford University has some great guidance. Rosa, if you could drop that Stanford University ventilation guidance into the chat, I would appreciate that. So these are just some guidance tools that you can go out to and take a look. Many of the stock rooms that I've been in just really don't have very good ventilation at all. One of the quick fixes that you can do while you're working with your administration and working with facilities to come up with better ventilation is to open the door to the stock room, the door to the classroom, and any windows in the classroom, and then bring in as much new clean air using like a box fan blowing into that chemical stock room, blowing that clean air in as much as possible. It is not an ideal situation. I wish I had better news for you, but the problem that we see all over the place is ventilation systems are expensive and they're difficult, particularly in really old school buildings, to implement and install. It can be done, however. There are a number of things called, well, there are snorkel hoods, there are some fume hoods that you can purchase. Stanford has a lot of good suggestions. If you find yourself in this situation, though, just know that it will take some time to design that system and to get it implemented because they are expensive. Okay, I apologize. I'm sorry that I don't have better answers or options for you. Ventilation is just tough. Adequate lighting is another thing that I usually see that's really lacking in chemical stock rooms. One of the things that I get a lot of questions about is, okay, well, if we change out the single light bulb fixture to let's say to an LED fixture, okay, where we've got a lot brighter light, that is a fantastic upgrade. And I'm going to encourage you, it usually doesn't cost a whole lot of money to do that. Light fixture in your chemical stockroom does not need to be explosion proof. Every once in a while, I'll get a teacher or an administrator who gets very concerned that, well, if there's chemicals in it, we need to make it explosion proof. That is not necessarily the case. What you need to do is really look at those chemicals that are off-gassing or putting out dangerous fumes and make a determination about whether or not you actually need the quantities that you have. We also, and I don't know that I've said this previously, I'm going to talk about it in the next slide, but we do not want to vent those flammable cabinets or corrosive cabinets. Okay, I know they come with vent holes, but all of our fire department guidance says, please do not vent those. What that does is it actually makes, if there is a fire, it makes those chemicals burn faster. So we want to be very careful about that. Now, one of the things that I would ask that you do is when you are looking around at your chemicals, you're selecting out what you're going to use. If your lighting in your chemical stockroom is lousy, instead of just using a standard flashlight, I think it's beneficial for you to have what's called an intrinsically safe flashlight. And I put an example of one here. You can buy them off of Amazon. They're available all over the place. They're relatively inexpensive, cost about 25, 30 bucks. And what they do is they work in an anti-sparking capacity. So there's no potential source for that flashlight to become an igniter if you stick the flashlight in a flams cabinet. We cannot say that about standard flashlights, okay? So it's in your best interest. If you're really going to dig around in the back of flammable cabinets, go through and pick out things that you need out of the backs of corrosive cabinets or shelving that may be improperly storing things that are flammable. You'll want to invest in intrinsically safe flashlight. And again, it's just a non-sparking, fire-safe flashlight that you can get off of the internet. All right. The next question or the next area that we're going to look at before we start moving things around are your shelving units. So I see a lot of shelving units throughout the United States in chemical stock rooms, and a lot of them have big holes eaten in them. So if you, excuse me, have been ruthless in your cleaning and you have some wonderful empty shelves, I want you to take a really good look at them. If those shelves have burn marks on them from chemicals that have eaten into them, if they have contamination, I want you to look underneath them at the clips. If the clips are rusty or degraded at all, those are shelves that likely need to be replaced. If you are storing things on metal shelves, like the metal shelf kits that you can buy at some of the box stores, I'm going to tell you that is not a great idea at all. And you really need to replace those with either wooden shelves or poly or plastic shelving. Okay. And I do not like plastic shelving, but it is better than metal shelving. Okay. Ideally, you're going to want wooden shelves, and even better is to purchase some liners for those chemicals, either shelf liners for the chemicals, or what I prefer and what we're going to talk about are poly containers or plastic containers, like under the bed storage boxes or totes that you store shoes in. You can get them at the dollar stores, Dollar Tree, Dollar General. I don't know what you guys have on the East Coast, but that is an ideal way to store chemicals by compatibility class and protect your shelving. Now, one of the questions that I get is, can we just throw away contaminated shelving? What if I find a shelf and it's got all kinds of, inevitably it'll be some weird white crystally creepy stuff that's already started to eat into the wood or the metal. Can you just throw that away? That is a very, very difficult question. I'm going to encourage you to work with your hazardous waste companies. See if they can identify what the contamination is and if it warrants being managed as hazardous waste or not. Please do not, if you have it highly contaminated shelving, please don't just throw it in the dumpster. We don't want other people exposed to that. And in addition to that, if it is hazardous, that's illegal disposal of a hazardous waste in most states. And it's just not a good practice. So if you do come across chemical contamination on shelving, work with your waste disposal company to see if there's an option for proper disposal of that, or if they can identify it. If they can identify it, or if there's been a box of cornstarch sitting there and it looks like cornstarch, and you can kind of make the assumption, which I really hate doing in chemistry stock rooms. But if it looks like it, if it's in the same location, if the box is leaking and you can draw those conclusions, then certainly anything that's non-hazardous can be cleaned up. But be very careful. If you really don't have an idea, be very, very careful about cleaning things up. Let's see. As we're looking at our chemical stock rooms, we want to also make sure that we're not storing chemicals above our heads. So the top shelf should not have any chemicals on it. If it does have chemicals on it, those are ones that we're going to be very careful about moving because number one, we've got elevated risk if we're reaching up over our heads to move those chemicals. We've also got some challenges with identification of those. And then finally, the flammable and the corrosives cabinets, we want to check the shelf clips on those. A lot of times those things will also rust and become very, very dangerous. I've put in the chat Rosa, if you could drop in there the web link for Matco. These are the best cabinets that I've come across over the years. And these are the ones that I would encourage you to look into purchasing. There are also specs available out on the internet for building your own I have had a couple of schools that have worked with their industrial shop folks, and they've built wooden, flammable, or corrosive cabinets. They put poly hinges on them, and they have shelf liners, and that is an excellent option too. Very, very good cost savings, and it gives those guys a project to work on as well. So ideally what we want for both flammable cabinets and corrosive cabinets are wooden cabinets. Rosa, if you could drop in that, or Karen, I guess, is on as well. If someone could drop in for everyone to see the link to the SciMatCo.
I have the Flynn Scientific Guidance. Is that the one?
No, that's Flynn. Oh, it's up at the top. It says flammable and corrosive cabinets. Looks like maybe you already did it. Oh, look at that. You did. I just wasn't looking in the right place. Perfect, Rosa. Thank you. It says flammable and corrosive cabinets, and then there's a web link to SciMatCo. Okay. Now, next thing that we're just going to touch on real briefly. I'm running out of time here pretty quick. But the next thing that I want to talk about is refrigerators. Okay, first of all, most refrigerators do not need, or most chemicals do not need to safely be stored in the refrigerator. In fact, there are very, very few that should be stored in the refrigerator. And if you do have any of those that say on the safety data sheets that they should be stored under refrigeration, really need to look and see whether or not the risk is worth it for having those on site and using them. If you do have that, if you decide that those are chemicals that you want to keep, then you're going to need what's called an intrinsically safe refrigerator. Can't just buy a regular refrigerator if you're going to store flammable chemicals in it. Intrinsically safe refrigerators are ridiculously expensive. So again, evaluate the risk versus the utility of those chemicals. Any of those flammable chemicals really should be stored in the flam cabinet, not in the refrigerator. Storing them in the refrigerator doesn't do anything to help extend their lives or keep them fresher. Those are kind of old wives' tales, so to speak. I would also encourage you that if you have anything that is a peroxide forming chemical, such as ethyl ether. Let's say you decide that you have to have ethyl ether for a particular experiment. Please do not store those in the refrigerator either. What happens is the refrigeration actually inhibits the inhibitor, so they can form peroxides more readily. And in addition to that, a lot of times they're off-gassing. And what you're doing is you're just building up those vapors in a non-intrinsically safe refrigerator. Creates a really, really big flammability problem. Refrigerators are fine to be used for biology, things like augers and that kind of thing, but please, no food. Do not store your lunches in with all the cultures that you're dealing with. Nobody wants salmonella or E. coli or anything like that resulting from something jumping off of an auger plate into your lunch, okay? Not a good plan. Make sure also that everything in the refrigerator, if you do store biology items in the refrigerator, that they're labeled unless they're consumer products. Like, you know, if you're storing celery in there, you don't have to put a label on the celery. We're talking about only chemicals in that situation. And then please make sure that you're cleaning that out about weekly. What we don't want to do is run into a whole slew of abandoned chemicals. Okay. So now we've got good shelf space. The shelves have good integrity. You've got your personal protective equipment on. You got a plan in place. So now we're going to start in on how are we going to organize these chemicals. And what I wanted to show you here is University of North Carolina at Chapel Hill. I borrowed their photo because I think this is an excellent example of what those trays that I'm talking about are. And you don't have to buy the trays from a science storage company or anything like that. Just standard plastic storage containers that you can get for $1 or $1.25 at any of the dollar type stores. Those make excellent secondary containment. What they're going to do is allow you to store chemicals by chemical compatibility class. They will allow you to also protect the shelving. Since shelving is a really expensive investment, we want to make sure that it doesn't have any chemical contamination on it. This is one really easy, inexpensive way to do that. One of the things we want to pay attention to, and we're going to talk more about this in our next webinar, is the OSHA hazard communication requirements for labeling. And those are located in 29 CFR 1910-1200. Rosa, if you could drop that link for OSHA hazard communication down into the chat so everybody knows where that section is. That's going to go through what are the labeling requirements for any containers that are in the lab. And I tell you, as a scientist, they still give me headaches, okay? Complying with that is really difficult. We are going to spend some time during our next webinar talking about that. A lot of reputable supply companies will provide you with pre-labeled stock containers. What you need to do if you dilute any of those is that you need to use the same labeling strategy that those companies did on the original stock chemicals. And then the other thing that I wanted to point out is that anytime we're dealing with shelving and we've got chemicals on it, we want to have a small lip on the front of the chemical storage shelf. And what that does is it prevents those chemicals from falling off. If we're working on one side of a shelf and something gets pushed, that lip is going to prevent any of those containers or chemicals from falling and breaking. And you can see here, this is an example from Flynn Scientific of a real simple fix for lips on retrofitting lips on the front of a cabinet. So what I want you to think about is containers, all that you're storing, all of them have to have lids on them. No parafilm on our shelves. So lids, lips, and labels, lids, lips, and labels. All right. Those are all critical pieces to keeping our stockroom safe. The easiest way to start sorting your chemicals from your stockroom by chemical compatibility is to actually label your containers, your secondary containment, those plastic containers that we talked about, label those first and set those out on the lab bench. When you set them out on the lab bench in the classroom, you have more space to work. And then you can start identifying chemical classes. You can start with the largest one first and move those out and then put them in the correct containers that are already labeled. Once you get done, then all you have to do is pick up that plastic container and put it back in on the correctly labeled shelf. There are a lot of different compatibility charts that are available to you. Flynn has a system. The American Chemical Society has a system. There's a whole bunch of different varieties of these out there. The next two slides, or the next couple of slides, excuse me, are a compilation of what I've used. What I find with the Flynn program, while the Flynn program is great, there are a lot of times that I don't necessarily see chemicals from certain classes that are even present. So the Flynn system tends to allocate a lot of shelf space that you may not use for those particular chemicals. You might not have any that you're using. So this is kind of if you have less space, this is a good strategy for separating your chemicals by compatibility. And what we're going to do here is, so what this is I want you to kind of squint your eyes and look at this and pretend that we're standing in front of your chemical shelves that you have cleaned out. Remember, we don't want any chemicals, no chemicals on the top shelf, no chemicals on the bottom shelf. So we're going to work with the main 3 or 4 shelves that are in the middle section. They are at eye level or below, and yet they're not so far down that you can't see, without climbing around on your knees, hands and knees, okay? In this particular situation, I set up that we've got 3 columns of shelving. So we've got 3 separate shelves that we're going to be working with, and then we've got 3 columns of shelving that we're working with. We want to make sure that you can see the green bar represents the shelf lip, and then we've got a shelf label on those. That's the little white box. So we're going to start with column 1. So the first 3 shelves, shelf 4, 5, and 6 of column 1. Remember, shelf 5 is the top one, doesn't have any chemicals on it. Shelf 1 is the bottom, doesn't have any chemicals on it. So shelf 4, we're going to start with inorganic reactives and metals. And likely this is going to be a pretty small collection, less than probably 5% of your total collection of chemicals. This represents Flynn scientific categories. So on each of the Flynn chemical containers, they'll have a number, a label identifying the category that they should be stored in. And this would be Flynn's categories I1 for inorganic, and I-10. Examples of these would be sulfurs, solid metals, hydrides, lithium, and sodium. Please make sure if you are going to keep lithium and sodium, that you are well aware of how old those chemicals are. You're using them up every year. They have about an 18-month shelf life, and that's it. Otherwise, they become peroxide formers, very expensive and dangerous to get rid of. Next column, next shelf down, shelf 3. This is going to be your largest class of chemicals. It may take you a couple of shelves on this because we're going to have a lot of stuff in here that everybody uses for their labs. This is Flynn Scientific Category I2, and this consists of our inorganic salts. So it's anything that's a chloride, an iodide, a fluoride, bromides. Fluorides and bromides, I want you to be careful with. I want you to pay attention to whether the risk exceeds the utility on those. Sulfates, sulfites, thiosulfates, phosphates, halides, and acetates. So those are the different chemical classes that we will want to use and store together. Once you have all of those I2s, those inorganic 2 salts pulled out, and you've identified where you're going to go with them, then you can put them in alphabetical order. So once they're in the class, alphabetical order is perfectly acceptable. However, if you don't mix them or if you don't identify by compatibility class first, you really should not store in alphabetical order. It causes lots of interactions and problems. So if you've inherited a chemical stockroom where everything is alphabetical, that's bad news. We want to move to where we're storing by compatibility class. Once you get the compatibility class together again, that's when you can put things into alphabetical order. Okay, next category are the inorganic oxidizers. This is going to be a fairly small category of chemicals. It's going to be considered, it's going to be things like nitrates, nitrites, borates, your chromates, manganetes, permanganates, chlorates, chlorides, and peroxides. There are a number of chemicals in this class that we want to make sure that we're storing in small quantities and that we've minimized risk by evaluating how risky they are and making sure that our risk level doesn't exceed the utility. Flynn categories here would be I3, I6, and I8. Okay. Next one. Now we're in the middle section of shelves. We're in the middle column of shelves. And again, top shelf, shelf 5, no chemicals. Bottom shelf, shelf 1, no chemicals. Shelf 4, we're going to include the inorganic corrosive bases. It's going to be about 10% of your total volume of chemicals. And it's things like your dry hydroxide. So sodium hydroxide, potassium hydroxide, your oxides, silicates, carbonates, and carbon. Interestingly enough, carbon will go here. If you are concerned because you have a high level of humidity in your stockroom, you can also put those hydroxides, because they are so hydrophobic, you can drop those into those gallon zip closed bags. And that's going to help prevent them from degrading and absorbing any liquids. Okay, the middle shelf in column 2, we're going to store our inorganic toxins. Okay, and this is another category that we've really got to think about. Do we really want these on site? Because some of these are going to be some pretty dangerous chemicals, high levels of risk, things like arsenides, cyanides, sulfides, selenides, phosphides, carbides, and nitrites. So I'm going to encourage you to minimize those as much as possible. You might not have very much, if anything, on this shelf. Also pay attention to the fact that some of these are going to have to be managed as hazardous waste. Anything with arsenate in it, anything with selenium in it has to be managed as hazardous waste. And some of the other categories will also have the cyanides are reactives and have to be handled as hazardous waste as well. Sulfides are considered reactives as well. So we got a lot of risk in this category. I'm going to encourage you to make sure that it's really that you're thinking about risk versus utility. And then finally, the lowest shelf in this column, we're going to store our organic toxins. Again, also a very small category of chemicals. This is Flynn categories 05 and 07, 04 organic 5s and organic 7s. Epoxy compounds, isocyanates, sulfides, and polysulfides. And again, should be a very small collection of your chemicals just because these are pretty high risk. Finally, we're in the last column of shelves, shelf 4, organic reactives. These are going to be less than 1%. And honestly, most schools don't have any of these anymore. Things like peroxides, azides, and hydroperoxides. It's the Flynn Science category 06, organic 6. Less than 1% of your total number of chemicals. And if this shelf is empty, it kind of makes me smile a whole lot because that means we've really paid attention to that risk minimization. Shelf in the middle, shelf 3 of the third column will be dry and dilute organic acids and anhydrides. And this is probably going to be around 1%, might be a little bit more because we do tend to see a lot of citric acid being used. But it's going to be Flynn Science category 01 or oxidizer class 1s. The anhydrides and the peracids, please be careful about risk there as well. Citric acid, though, good thing to have on site. We have a lot of schools that use that, very useful chemical. Finally, column 3, shelf 2. So this is our last one. We can put, Flynn calls these household goods. So this is where we can put our things like our dyes, stains, augers, sugars, anything that's basically kind of a household product. We can store vinegar here. It is dilute, very, very, very dilute acetic acid. So you can either store vinegar only on this shelf, or you can put your vinegar in with your corrosives cabinet. Once again, once you get all of these categorized together, or the chemicals that are compatible in this area, they can be also be alphabetized for easy finds. Okay, these are the unique things. Okay, so we're going to call some of these out. First of all, our inorganic acids. So we want to make sure that we're storing our inorganic acids in an acid cabinet. This is going to be about 10% of your total volume. Chemical classes that are going to be in there, these are the Flynn scientific categories that are I9s, hydrochloric, sulfuric, phosphoric, perchloric acid. We do not want nitric acid in that inorganic acid cabinet. Yes, nitric acid is an inorganic acid, but it is so reactive and such a strong oxidizer, not a good place to put it. So what we want to do with nitric acid is we want to, actually the best way is to get another 5-gallon bucket with one of those special screw top lids, label it nitric acid, the same as what the Flynn label says, all of the pictograms and information. So it's GHS compliant. And we want to make sure that we put that in the nitric acid in an absorbent material and then close the lid. We're also not going to store our glacial acetic acid in here. It reacts with a couple of things, and it is a flammable. So we want to store our glacial acetic acid in with our flammables. Flammables and organic acids are going to be stored together. Examples of things would be like the alcohols, glycols, phenol, hydrocarbons, any of your solvents, cresols, esters, and ethers. I really want you to look at that esters and ethers to determine if the risk exceeds utility again. And then we're going to put some other organic acids in there. Propionic acid, so the liquid organic acids along with glacial acetic. And then I skipped over the middle one, which is inorganic bases. We want to store those in a cabinet that's poly or wooden, and those would be your solutions. Okay, so not your dries, your solutions. Things like ammonium hydroxide, sodium hydroxide, calcium hydroxide, potassium hydroxide. Okay. Okay, so specialty things, that poly 5-gallon bucket, most useful for nitric acid. Large chemical containers that don't fit, we're going to have to identify a location for those. And then as far as general notes on cabinet storage, we don't want to vent those cabinets. Acid and caustic specific spill pads are available, but the universal spill pads that I had on your spill kit will work just fine with those. And using secondary containment in those will help maintain those cabinets as well. Now, safe storage of waste, and I apologize, I'm going to have to buzz through this really quickly, but basically we're going to set up the same type of system for hazardous waste that we've set up for our chemicals. We want to store our hazardous waste by compatibility class. We want to make sure that the container that we've collected the hazardous waste in is labeled properly. We'll talk more about that next time. We want the words hazardous waste on that container, the date that it was generated, and a hazard description. There may also be some specific state requirements, so pay attention to what else is required on those hazardous waste labels. You want to coordinate disposal with your site contact, either facilities or whoever that's going to be, your chemical hygiene officer maybe. And we want to make sure that, again, we're not putting any of this down the drain, up the hood, or in the trash. We don't want to store caustic and corrosive chemicals in dropper bottles. So please make sure that when you do make up small quantities of solutions that you use them up at the same time as the lab is happening. Hazardous waste can be combined by compatibility, but I'm going to encourage you to talk with a waste disposal company before you do that. One of the things that's a good strategy is you can have waste on one side of a cabinet or a shelf and the same compatible chemicals on the other side of the shelf. So you see on the picture here, we've got a sign up at the top that says left side dispose, right side keep. So our stock chemicals are on the right, our waste is on the left. In this picture, they do not have the waste marked correctly. Okay, it's not compliant, but it gives you an idea of how to separate those. Probably the biggest favor that you can do to yourself is to make sure that you are evaluating all the chemicals that you're using in your labs to see if there are easier to manage alternatives that are not hazardous waste. Okay. All right, so best options here, and this is a really cool little trick. But one of the teachers that I worked with years ago at West Des Moines School said they were having troubles identifying who was using what. So what she did is she selected these tiny dots. She called it the tiny dot tracking method. And she taped up a whole bunch of strips of these tiny dots in her stockroom. And if anybody pulled a chemical to use it or make a solution or whatever, they would put a dot on the top of the chemical. Each year would have a particular dot color. The teacher would take it, and every time they used it, they would put a dot on the top of that chemical. By the time they got to 3 years, 3 different colors of dots, if they had chemicals that had no dots on the top of them whatsoever, they knew that they could probably dispose of that chemical and get it out of the stockroom because nobody was using it. Make sure that you have some way with your colleagues to track who's using what so that we're not getting rid of things that we do need. And also so that we're minimizing our risk by eliminating things that don't need to be in our stockrooms. Our next webinar, we're going to talk about evaluation of chemical risk on safety data sheets. And we're also going to talk about hazard communication compliance under OSHA. What's required for labeling. When I say pictograms, what the heck does that mean? We're going to also focus a lot on toxicology and understanding how do you use the safety data sheet to evaluate whether or not you want something in your classroom. Steps you can take today: make sure that you're paying attention to chemicals that should be disposed or replaced as you move into chemical storage. Assess the equipment in your classroom. Be ruthless in that evaluation in what you keep and what you get rid of to give yourself more space. Minimize your risk through segregating things properly. Minimize your risk to colleagues by labeling things, and then also labeling your hazardous waste. And then finally, remember RAMP, which is recognize, assess, minimize, and prepare. And then attend webinar number 5. It's coming up in 2 weeks, where we'll talk a lot about hazard communication and safety data sheets. Here's my information. I apologize. I went a couple of minutes over today. The previous webinars in this series are available, or they will be soon. I'm having some technical issues getting them on my website, but I'm hoping within the next few weeks that I have those posted. And if you, my website is on this last slide here. So just kind of keep checking back. And I'm hoping to not only have the webinars, but also to have a whole series of resources for teachers and administrators. All right, do we have any other questions today? We've got about 25 minutes left available to us if we have any other questions.
Becky, there was a question on the chat from earlier from my Karen Legals. She asked, what about ductless fume hoods?
Oh, ductless fume hoods. Oh boy. I haven't had a lot of schools that have implemented the use of the ductless fume hoods. They require much more maintenance. And frankly, I don't know a whole lot about them. I know they're very expensive and they require less or quite a bit more maintenance because you have to make sure that they're filtering properly and that the flow rates are good. And they have to be, the filters on them have to be changed out. And I'm not familiar with all the different chemicals that would be absorbed by those filters. At one point in time, I worked with an insurance company that was very interested in implementing those. But frankly, I just don't know how far that went. Most of this, the schools that I've worked with have put in dedicated ventilation from the stock room directly to the outside, and then made up air exchanges so that they constantly had those 6 to 7 air exchanges per hour in the rooms. I just have a lot more experience there. One of the other options are snorkel hoods. They also typically tend to be direct vent as well. So Karen, if you want to reach out to me, I can help you identify whether or not that would be a good option for you. I think it also kind of depends on, what solvents you have in your lab and what other toxins in particular you have. Okay. Anybody else have any other questions?
There was another comment in the chat that came through from Becky Wortman. She commented on UVEX Flex Seal goggles.
Oh, that was me.
Was that you? Okay,
That's
sorry
me.
about that. Okay, sorry. I didn't
That's
realize
okay.
it.
Yeah, I
But
just put
there
it in
was
the chat because those are my favorite Flex Seal. Those are my favorite chemical resistant goggles.
Okay. I'm not sure
Okay.
if you can get to the question box, or they just, one of them came in. Our
Yep.
previous webinars in this, is this a series available?
Yeah, I talked with that we're going to try to put the series up on the website. I'm working on that. And I see we now have another question in there. Have you seen issues with chemical kits shipping with incompatibles? Let's start with that. Kits shipping with incompatibles. Yes, that is a pretty common practice. And the way that they get away with that is the packaging that the chemicals are in, as well as they use what's called a limited quantity exemption under DOT. So there's a few little games being played there, which are not good. When you get those chemical kits, if you identify that they have incompatible chemicals in them, let's say they got an oxidizer right next to a flammable, very, very bad combination. I don't care how good the integrity of those little bottles is, not a great combination. You'll want to take the flammables out and put those in your flam cabinets. And yeah, I'm a really strong advocate for those kits. I love using them. I use them a lot when I teach OSHA safety classes, chemical safety classes for my industry folks. So they're a great option, but unfortunately they are shipped with incompatible chemicals, and it's legal because of a DOT exemption. So I would encourage you to take those apart, make sure that you know how to store them safely. And what I've seen a lot of teachers do over the years is they actually write themselves like a little note that goes, a lot of those kits will come with instruction sheets in them. You add on one more page to the instruction sheet that says, hey, these chemicals are located in, shelf 2, inorganics, shelf 1 of my flammables. So make yourself a little note there, and then put it back in the kit. That way, any teachers that are behind you can also find the information and figure out what happened to those little containers. Next question is, what do you recommend staff do if they're looking for the convenience of kits, but also separating out incompatibles? That's the one that just, put a little SOP, standard operating procedure, that says, hey, these chemicals were pulled out because they're not compatible and we put them in the right place. And then you've recommended a sticker method. We've recommended a sticker method or keeping a list. Yes, I agree with that. So, and the little tiny dot method, I've helped a number of teachers implement that over the years, and it's like magical. It costs like $2 for a strip of those dots. And all of a sudden it's easy communication between all colleagues of who is using what. So, all right. Anybody else have anything else? Any other questions? Okay, I know that Vermont and New Hampshire are getting massive amounts of snow and muck right now, so I hope you're all safe. Okay, Rosa, I think that's all we've got for today.
Thank you.
Okay. Thanks so much, everybody. I appreciate it and hope to see you in a couple of weeks at our next webinar. Bye-bye.